In this video, we will see how we should not set up an MBX1 to simulate a 640 server from IEDScout software application. Before we start simulating a 640 server from IEDScout using MBX1, we need to know how we set an IP address for the control ports, also the station ports at the front side of the MBX1. So we also provide this information in the help section of IEDScout. So after we open IEDScout software application, there is a help icon in the top right corner, so that we can able to select the question mark and then icon, and then we can able to see different menus in the left side. There we can able to expand the MBX1 and RBX1 platform. So there we do provide the information about the IP address assignment in order to use or connect the MBX1. So here we could able to see the IP address that we do assign for the control port of the MBX1 must be different than the subnet that we do assign for the station ports. So this is very important that we need to know when we are using MBX1 to perform the simulation with IEDScout software application. Even for Station Scout as well, the IP address should be different than the control port to the station ports for the security reason. So in this case, I will show you the IP address that I have in my PC. Control ports. The control port I have assigned 192.168.2.15 at the moment, and then I will just show you the IP address that has been assigned to the station ports. So in the station port, the port number A, I have an IP address assigned 192.168.210.197, and then let's take a real example. I have a real IED in my network that is connected to the station network, station port network of the MBX1. So the IP address is available here in the property that we can able to see from the PSIM600 software application to manage the ABB IEDs. So here you can also see there is a green color tick mark. That means the IED is available in the network. And let's export this complete SCL file as an SED. By selecting the substation section, we could able to export the SED file for the whole substation for the ABB make IEDs. And here we can able to see that edition can be chosen flexibly depending on the 620 SL schema that is really required. So we can able to export the latest schema, which is also completely fine for IEDScout to simulate, and we support to simulate all different edition 620 edition IEDs. So the IEDs are getting exported to the SED file, and the export is successful. We can able to see in the output window of the PSIM600. And here we can able to come back here and then try to go to the simulate IED, then open the SCD file, and then here we need to import the right IED. So here we can able to see the ID name here, Q02A1. It's finishing with Q02A1. So this is an ID that we will try to simulate in the wrong way. This is to explain how we should not simulate by having a similar IP address or the same IP address in the network. So let me try to start simulate. Here we can able to see the IP address 192.168.210.125. Then if I try to assign an IP address on the same range to 10.125, then try to apply, then give OK here, and then let's go for simulation, and we can able to see now it's failed to apply the IP address because an IP address has been used in the network already. So we need to set a different IP address. This is also very important. For example, even let's go further. This is one of the use case that customer used to try in a wrong way, which we don't recommend. So there is another ID which is not actually available in the network. That's 192.168.210.161. So this is another remote desktop connection which I have taken to set the same IP address. So this is my station bus IP address. I can able to assign the same IP address here. For example, 192.168.210.161, for example, which is not available in the network. And there is an IP address that I have assigned to one of the PC adapter that is connected to the network. Then if I try to simulate this particular ID from IEDScout using MBX1, even configuring the different IP address correctly on the station port, and if you are trying to duplicate the IED, for example, let me try to import again another IED, which is this one, the 161. So here we can able to see when I try to simulate and try to duplicate this IP address, which is already assigned to one of the network adapter, which is connected to the same network. Try to simulate, and we could able to see the IP address has been used in one of the network adapter, which we have seen now in the previous step. So this is how we should not try to simulate an IED from IEDScout, because the MMS server, when we try to simulate, it also works based on the TCP/IP connection. It required the request and response from the client and server. So in that case, we should be able to use a unique IP address to perform the simulation correctly from the IEDScout using MBX1 or even IEDScout PC license. So we need to go back here, then we need to remove the IP address that has been assigned to the one of the adapter. So there are several ways to find out the duplicate IP address. For example, you can use the advanced IP scanner to figure out what are the different IP address available, and then you basically can able to remove such a duplicate IP address. Then set here, close, fine. Then you are good to go here, and back you can just simulate an ID. So now it should simulate successfully without any problem. And you can also able to see the error messages that can also help you sometime what exactly the problem and what you need to do. So this is how we can able to get more information, what exactly happened in terms of the error codes, and can also further contact us. Most of the error handling that are available in the IEDScout or StationsCout or any other Omicron software solutions, testing solutions, provide that top level clarity on the user interface. But if you need more information, you can always feel free to contact Omicron technical support, and we will be happy to support you. And simulation is successful, and we can able to even manage flexibly the GOOSE configuration, the control block that we are publishing it. Then we can able to even perform the client server communication testing. For example, we successfully simulated here, and from the other PC, this is another client PC which we can able to use to discover the simulated IED and perform different application testing, like enabling the reports and pulling the value from the MMS server that we have simulated. So there are many different use cases which we can able to achieve. For example, I have simulated an IED from IEDScout here using MBX1, and I'm subscribing the GOOSE messages here in the another physical IED that is available in the network. Let me go to the application configuration to show you clearly simulated MMS server. So the GOOSE control block are really working perfectly or not in the simulation environment. I'll try to cover some of the basic use cases quickly at the moment. So we have opened IEDScout in another client PC. So there are many updates going on in the backend on this same PC, which I have taken in the remote desktop connection. So now it's stable. So let me discover the IED, which I have. So the IP address is same, which I have simulated from the other PC, from my testing PC. And let me try to discover the IED. And we successfully discovered. And then we can able to even see the GOOSE control block, which has been published from the simulator. Then we can also able to even see by selecting the subscribe GOOSE to make sure the GOOSE messages are really available in the network or not. And then we can even able to see the simulation bit has been enabled by default when I simulated from the IEDScout. In a real environment, it's very important to enable basically in the real substation to make sure that the other subscribers, which is working in a normal mode, should ignore the simulated GOOSE control block from the simulated test set. I can even enable the reports from the client. For example, I will go to the one of the report control block instance, and I will try to even enable the description section so that I can able to get more insights about the different level of section that I can able to select in the IED navigation menu. In the detail menu, I can able to see in the middle screen there is a center column. I can able to just see what is the exact information about the data objects and data attribute. So in this case, I will try to just drag and drop this data objects. So it's belong to the report control block. I can even enable the reason for inclusion to know why this particular data I need to report to this client. So the owner is my PC here who occupied the report control block. And at the moment, there is no data change or any other trigger option, which is really required to send the data from the simulated IED. I can start the sniffer here. I can able to uncheck the GOOSE message because we will try to focus on the reports first. And we'll go back to the simulator environment, another PC. Here I can able to just quickly check in the other IED I can able to even see. Let us first finish the report control block. The simulated environment can able to just go to the control logical, no logical device. Then we can able to see the switch controller for the circuit breaker. I can able to see the control model here. I can able to just drag and drop. I can able to just make it in the off screen. I can able to just see the other PC in another off screen. So let's try to give the command from the client application. So I select the data object, which is having the control model with enhance select before operate with enhanced security. Then I can able to just select the control data object, and then I can able to just see the current position, which is in off condition. I can able to just select the on position, then select operate. Then I could able to see in the right side the position has been closed in the server side. So the IEDScout can able to receive the command from the client device, and we can able to even flexibly simulate from the other side to make sure the data has been sent correctly or not. In the sniffer, we could able to see the report has been sent from the simulator device. The data change happened. So before the position was open, and we selected the data attribute for true to perform the close command. And then there is another data update happen for the reports that has been sent here, and the position has been changed, and then the data attribute has been reset. The select close, the position select has been false from true. So these are the data change, and the client could able to get this report. We can even able to export this test report as a PK files, CSV file, in order to send it to another person who wanted to visualize this data. Even by saving the CL file, we get more clarity in offline itself. And we'll go back to the GOOSE application testing. So on the right side, we have the can able to uncheck the project on the right side. So here we go. This is a GOOSE interlock receive function block. Where we can able to subscribe the GOOSE message for the double point status for the interlock applications. So here I can able to see this particular ID is not receiving the GOOSE message at the moment because we are simulating by default with I simulated by default with the simulation bit enabled. So I can able to just select the configure GOOSE option in the top. There is a small icon. I can able to stop the GOOSE message in the right side in the PCM600 at the subscriber GOOSE subscriber ID. The communication validity is 0 at the moment. When I can able to zoom in a little bit extra to make sure the visibility is available completely. So the communication validity is 0 because we are simulating from the test set with simulation bit enabled. So let's stop the GOOSE control block publishing, and then I can able to just uncheck this simulation so that now the IED will look for because the IED is set to receive the GOOSE message from the normal IED without the simulation flag enabled in the GOOSE control block. So here I could able to see the communication validity is 1 and it's processed now, and I could able to even see the value. The position is off now. I can able to change it to on. So this is the data attribute that I am publishing from the IEDScout as a GOOSE publisher. I can able to change the value and then update. Here I could able to see that the value has been processed. for the IEDScout simulation. So this is how we change the data easily. So let me update off position, and we can able to see the double point state value here at the subscriber side. And in case if we want to do test in the real environment, and what we can able to do, we can able to go to the browser section, and then we can able to discover the IED. So the IED which we are working is having an IP address of 192.168.10.125. Let's discover the 125 IED. So at the same time, we can able to use IEDScout as a client as well as server application. So both are supported. We can able to even publish the GOOSE messages, publish the MMS server contents, and we can also able to parallelly use IEDScout as a client application. So we can able to even see the IEDScout can discover the data model, and now we are using IEDScout as a client application for the real ID. And we can able to now go to the data model. Then there is a LD0 and LL0. Sorry, there is a LPHD logical node. So it's common for all other IEC 670 supported ID from different manufacturers. So they used to manage the simulated simulation features, so whether the IED can allow the simulated GOOSE and sample values. So we can able to enable the description to know this information more in detail. Maybe I can expand it so that we can able to understand. So at the moment, the client device is set to receive the GOOSE messages and sample value data from the real device. That's why we could able to see the data status as a false. So in case if you wanted to receive the GOOSE messages and sample value from the simulated test sets, we can able to set it to true, this particular value, and it succeeded. This particular settings need to be even enabled in the PCM600 ID configuration tool. So there is a dedicated setting in order to manage this setting remotely from the client device. For example, there is a communication section, station communication. There we have the IEC 620 simulation mode. So this particular setting need to be enabled before we perform the simulation bit control command from the client devices like IEDScout. So here we can able to see the allow simulation value is true. So in that case, we can able to set the value from the client devices. If it is false, means no, in that case we need to set it as in order to perform these changes from the IEDScout. So let's go back to the PCM600 and then application configuration. Then I can able to disable this, and here I can able to see the communication is valid. I can able to now even process the data with the simulation bit on. I will stop the simulation and I will enable the simulation. Then I will start publishing. Here we should be able to still receive the GOOSE messages at the moment. So in that case, I can able to change the on status, then update it, and here we should be able to receive the position in the real ID, so that we can able to even use IEDScout in the real environment to manage the simulation bit true. So that in that case, we need to enable the allow simulation bit for the subscriber ID. So this is how we manage it. So we can able to make it false and operate. So this is how we make it to work correctly when we are simulating a 650 server from the IEDScout. So in case if you need more information, please feel free to contact us on Omicron Technical Support. We will be happy to support you in case if you need more information. So here you can able to see the Omicron webpage. In a few seconds, it's getting loading. So in the Omicron webpage, there you can able to go, and then there is an option for technical support. And under the support menu, there you can able to see the different support line emails, and you can able to choose flexibly depending on the location where you are and the regional technical support responsible person for this application able to support you to provide the right solution for your problem. Thank you. Take care. Bye.